Good morning. Today we are continuing with those prime factors. Today we are talking about CO23. I can find the greatest common factor of a set of numbers. So we're working on finding the greatest common factor this time. Yesterday we broke it down with that prime factorization to find all of the primes that go into a number. Now we're looking at just the greatest common factor. So to do that, we need to know what factors are. A factor is a numbers that go evenly into a given value. So factors are those numbers that go evenly into the number. Factor buddies. 2 times 3 is 6. So 2 and 3 are factors of 6. So the factors are you multiply it together by another number and you get that big value. So an example would be 2 and 9 are factors of what number? 18. Because 2 times 9 is 18. 6 and 5 are factors of what number?
20. No, sorry.
30. Yep. So you have to be careful. It's really easy to make simple math mistakes when we look at these factors. Okay. So you just have to slow down and really think about your multiplication facts. There are 3 methods we're going to go over to find the greatest common factor. The first one is we're going to be using that prime factorization we worked on in CO22. And I'm going to show you how we're going to use that to find the greatest common factor. So when we did prime factorization, we did that with just one number. Now we're comparing numbers and we're finding what's the biggest factor they share. So we can do that using prime factorization. We can do it with a listing method, and we can find that greatest common factor doing a table. So I'm going to show you each of those methods. Some methods will come easy for you. Some you might have to think about. But I want us to really try all 3 methods because sometimes a method will work with certain numbers better than others. When you have super big numbers, doing some of these is going to take a lot of work and you might want to do an easier way. So, first way we're going to do, well, let me erase and move this up so we can see better. First way we're going to do is that prime factorization. So we're going to make those Christmas trees and we're going to do it for each number. So we have 18 and 15. So if I'm going to do a factor tree for 18, what could I break that into, Olivia? 6 and 3. Can I go any farther? Can I break down my 6, Isabel? To what? 2 and 3. Can I break down my 3?
No.
No, so that's going to stay 3. I still bring it down as I'm making my tree grow as it gets bigger. So my factors are 2 times 3 times 3. This is what we did yesterday. We're going to do the same thing for 15. What can I break the 15 into? Isabel? Oh my goodness. Amelia, I'm sorry, I pointed to you. Amelia?
3 and 5.
3 and 5. Can I break down my 3 anymore?
No.
Can I break down the 5 anymore? No. So my prime factorization is 3 times 5. So I'm going to look at that to see what my greatest common factor is. The way I do that is I'm going to compare my primes. I'm going to say, ooh, they both have a 3. Do they both have a 5?
No.
No, so I can't put that down below. Do they both have a 2?
No.
No, the only factor that they shared is that 3. So that is the greatest common factor of 18 and 15. Get out your whiteboards. We're going to do another one. Quietly, I'm recording. If you did not come to class prepared, you're just going to use the white paper next to this objective. There is nobody leaving. Sit down. You are going to use the white paper on the other side. Your binder is open. Use that blank paper next to it. You need to come to class prepared.
I had it in my.
We are going to put some numbers onto our paper, or onto our whiteboard, or the paper next to you. Let's do 45 and 27. Do the factorization, prime factorization. We're going to make our trees for both of them. $45 and 27. Yep, you're going to make your factor trees for both of them. Bless you. So you should have gotten down to your prime factors of 5 times 3 times 3 for 45, 3 times 3 times 3 for 27. Now, well, it's because you weren't here yesterday. You're going to practice it and you'll get better. Now I'm going to show you what we do with this. People said, oh, we share 3, we share 3. And then people said, oh, that's it. Because they shared another 3 and another 3. You can't just put that 3 one time. They shared 2 3s. So it's going to look like this. 3 times 3. Because they shared 2 3s. What is 3 times 3? 9 is our greatest common factor. 3 is the smallest, the least common factor. We want to find the greatest common factor. So you're going to circle every factor that they share, and then you multiply them together. So they shared a 3, and then they shared another 3. So then we have to multiply those together. 3 times 3 is 9. Yep, we're going to do one more. This time we're going to do it with 3 numbers.
What happens if they both share 3?
I'm sorry, what was your question?
They both share 3.
Say it again.
Would you do the same thing if they both have 3?
Yeah, you do 3 times 3 times 3. Okay, our next one, let's do hello, this cake. You sure can. Yep, bye. So make sure you watch the recording to finish this up. Okay, so when we're breaking down our numbers, remember we're breaking down to those primes. So we had 2 times 5 for the 10, 2 times 3 times 5 for the 30. 5 times 13 for 65. Then we have to circle what primes that all three of them share. Do they all share a 2? No, so I can't do the 2. Do they all share a 5?
Yes.
Do they all share any other number? No, there's no more numbers here. So that is our greatest common factor. What if I had made this, I don't know, what if they had shared another one? Remember, you multiply what other factor they share. So you circle all the factors. This one, they only shared one factor, but I showed you in the last one, if they shared 2 factors, you multiply them together. If they share 3 factors, you multiply all 3 together. They share 4 factors, you multiply all 4 of them together. Okay? Do you have a question, Jillian?
Yeah, why is it like in fractions like the least common, not denominator, but like the least?
It's a good question. It's a whole different kind of number. Okay, we're working with whole numbers, we're not working with the fractions, so we look for something different. And actually though, in fractions, when you are simplifying, you want to find the greatest common factor, so you only have to simplify it one time. So think about when you simplify a fraction down, we're looking for what is the biggest number they both share. Because if we find those smaller numbers before we multiply them together, we have to simplify it several times. All right, let's look at our next method. Our next method is, oh, this is a multi-page one. He only gave me one page. So you know what? Let's do, so let's do the 42 and the 30. I didn't realize it was multi-page because he only gave me one. So let's do the 42 and the 30. We're gonna do it right in your book together. So my 42, I like to go down to my 2's when it's an even number, because I know 2 is gonna be a factor when it's even. So I always factor out my 2 first. So 2 times 21. 2 you can't break down anymore. 21 we can break into a what? 3 and 7. 2 times 3 times 7. 30, 3 and 10. Can't break my 3 down anymore, but my 10 can be a 2 and a 5. So that's 2 times 3 times 5.
Wait, can it be in other ways too? Like 42?
Yeah. Yeah, it can be put in different.
So you can start with any factor pair. We talked about it yesterday. You missed that. You can start with any factor pair. You're going to end up with the same prime factors at the end. So it doesn't matter how you start. We end up the same way. So here we share a 2 and we share a 3. So we multiply those together. So our greatest common factor is 6. Does that make sense?
Yes.
All right, you start working on the 12, 30, and 60. We're going to see if we end up with the same factorization. You can write on your whiteboard what you think the greatest common factor is. me see yours on your whiteboard when you get it done. Put your answer on the whiteboard, I said. So when you get it done, put your answer on the whiteboard. So then you have to find the greatest common factor. So you got it to the prime factorization. Now find the greatest common factor out of it. You see what you missed?
Well, I didn't really, but like, oh, now I see what I mean.
And they shared the 2 and the 2 and the 2. So you have to multiply them.
I was doing things.
Oh, you forgot to break the 4 down? Wait until we're done with the lesson. So Luciana's a great question. She said, does it matter how many 2s and 3s we have? So what you do is, I went to my first 2, and I said, okay, there's a 2 here, and there's a 2 here. I accidentally did that one. So ignore that. You have to look at your prime factorization. You just about it. So I wrote that 2 one time, because they all shared 1 2. Then I went and looked, do they all share a second 2? This one does not have a second 2 in it, so I can't write 2 again because they don't all share that second 2. Then I went to the 3s, and I see that they all shared a 3, so I could write that. And then I had to multiply them together. So you can only circle a number if it's shared by the other numbers. This second 2 wasn't shared a second time with my 30, so I couldn't put that down for the greatest common factor. You can only put down the ones that, as you circle it one time, write that number down. Then go back to circle for all the numbers again, and if you can't write that number down low. Did that answer your question? Okay. So then we had, they shared a 2, 1 2, and they shared 1 3. So 2 times 3 is 6. Greatest common factor of 6. All right, let's look at our listing. So for the listing, you're going to write your numbers on top, just like we did for our prime factorization. And then we're going to list underneath
Can we do 5?
what the factor buddies are.
5 and 5?
5 and 5. 1 and 25. Are there any other factor buddies? No. So now let's look at the 40. What are my factor buddies for 40? Isabel?
8 and 5.
8 and 5. Aiden?
2 and 20.
2 and 20.
4 and 10.
4 and 10. 40 and 1. Are there any more? Nope. So I'm going to look at my 2 sets, and I'm going to circle the biggest factor that they share. So I'm going to start with the 25 because there's less numbers there. So I'm going to say, okay, does 40 have a 25 in it? No. My next number is a 5. Yeah, they both share the 5. That is my greatest common factor. When I said we're doing the whole first page together, we're just going to do the first 2 for these bottom ones. So let's look at 24 and 36. We're going to do the same thing. List all the factor buddies and then find the biggest number that they share. So this time you're going to list on your own And then on your whiteboard, you're gonna put what you think the greatest common factor is. So you work it out yourself, put it on your whiteboard, and we're gonna see if we come up with the same number. Okay, seriously, friends, I am recording and you are not paying attention and concentrating. I should not be hearing comments like that. We are working. We're not talking like Gollum from Lord of the Rings. Please stop distracting your table mates. So you should have your list of factors. 24 has 4 sets of factor buddies. 36 has 5 sets of factor buddies. You're going to look. I'm going to go to the set that has the least. I'm going to start with the biggest number. 24 is not in 36. Next number is 12.
They both have 12.
They do both have 12. So always start with that biggest number and check to see if it's in the other side. The hard part about listing is sometimes we forget some of our factor buddies. Notice how I organized my factor buddy list. I start with 1, then I go to 2. Is 2 a factor? Is 3 a factor? Is 4 a factor? Is 5 a factor? Is 6 a factor? Is 7 a factor? Is 8 a factor? Is 9 a factor? Is 10 a factor? I start with 1 for a reason. So that way I go very organized so I don't miss any of my factors. Because it's really easy. I saw some people putting 6 down there and saying 6 was their biggest factor because they missed one of their factor buddies that had a 12 in it. Okay, so when you list, you have to make sure you go in an organized manner so you don't miss any factor buddies. If you just randomly think, oh, 36, I know that's 6 times 6, I know it's 4 and 9, and 1 and 36. If you're just hopping around with your numbers, you might miss some. So again, I always start out with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I didn't write the 9 again because I already had it listed. So I knew I didn't have to write the 9 again. So I didn't have to do 9 and 4 because that's the same as 4 and 9. That way I don't miss any of my factor buddies. How do we feel about listing?
Good. Yeah.
Okay, the listing though, it seems easy, but it's easy to make mistakes on it. All right, you're gonna do the 3 numbers on your own. Let's look at the table. When we use a table, we are going here. We did 21 and 35. And we could say 7 times 3, 7 times 5 is 35. Okay. It's a little bit more it's a little bit more abstract using the table, right? So we know that the 7 times 3, 7 times 5 works for each number. It's a little bit more confusing how to use the table. Do they share any other factor? That is the only one that they share. So we know 7 is our greatest common factor. Let's look at the 15 and 50.
Wait, can we do the 3 or oh?
We have to think of what factors they share. What factors do you see I see a 5 that they share. 5 times what is 15? 5 times what is 10? Is there any other factor that 15 and 50 share? Because 15 doesn't even go into 50. That's the only factor that they share. So our greatest common factor is 50. Let's do, sorry, 5. It's been a long day already. So we have 14, 28, and 49. What factor do you think I should start with? 7. 7 times what is 14? 7 times what is 28?
4.
7 times what is 49?
7.
Do they share any other factor? No, they don't. So our greatest common factor is 7. That one's a little bit more confusing. Okay. On the second page, it says pick your favorite method. So that table one is a little bit more confusing. You don't have to redo any of those if you don't want to do the table. You could do the listing or you could do the prime factorization. So make sure that you don't forget to do 8, 16, and 48, doing the listing. Remember I said you're going to do that on your own. Then you're going to pick your favorite method down here, show your work. You are not just going to look at it and do mental math and tell me what the greatest common factor is. Show your work. Doing one of those methods. Show your work. Let me say that one more time.
Show your work.
Then on the bottom, whenever you're given a word problem that includes the phrases identical and all of the items, you'll be using the greatest common factor. Here's an example. Mr. Schultz is making lunches for his children. He has 8 sandwiches, 20 beef jerkies, and 12 strawberries, and 44 gushers. How many identical lunches can he make using all of the items? You need to find the greatest common factor of all 4 of these numbers. 8, 20, 12, and 44. So use one of our methods and find the greatest common factor. And then just for funsies, how many of each item will be in each lunch? So if you know what the greatest common factor is, and you know what the total number is, can you tell me how many would go in each of the lunches? It would be its factor buddy. So let's say that there are 36 strawberries. No, not strawberries, that's already in there. Let's say 36 apples. And we knew that we were breaking them into 9 was the greatest common factor of what they all were. If there's 9 lunches and there's 36 apples, how many apples would be in each lunch? What's 9's factor buddy? 4. 9 times 4 is 36, so there would be 4 apples in each of the lunches. So you know your full number, you know how many lunches there are. To say how many of those would be in each lunch, it's just its factor buddy. So if there's 9 lunches, 9 times 4 is 36, so there's 4 apples in each of the 9 lunches. That'd be a lot of apples to eat. Does that make sense?
Yeah.
So to do the just for funsies, just write down each of their factor buddies for how many lunches there are. And then you're going to do the review. So, greatest common factor, prime factorization, we knew how to do that yesterday. Then you multiply together the primes that they share. Listing, you have to make sure that you list all of the factors. And the table is not so easy to use because you have to find that greatest common factor right away. It gets a little bit more complicated. So if you want to use that, you can. Just make sure you're finding the biggest one. So on the first page, make sure that you go back and you do the one that we did not do. List for all three of them. Okay, so list for all three. Then on the second page, pick your favorite method. You could do listing for one, you could do prime factorization for another. You only have to do one method for each set of numbers. Then do the word problem, then do the review. Any questions on today's assignment? Isabel?
Wait, so on the back for the top 6, you can just do one for.
You only have to do one method. You can mix up and do different methods, but you only have to do it one time for each set of numbers. So for 18 and 45, you can do prime factorization. For 24 and 54, you can do prime factorization. For 60 and 12, maybe you want to list them this time. So it doesn't have to be the same method for each one, but you only have to do one method per set of numbers. Jillian?
For the listing, if we have like multiple factors, do you have to times it by the other one? Like if you have 3 and 6 for a factor, would you times 6 times 3?
When you're listing, you're not multiplying anything. You're just listing all the factors, and then you're finding the biggest number that all the numbers share. So if we had 18 and 45, you're listing all the factors of 18, then you list all the factors of 45. Start with the biggest number and work your way down. What's the biggest number that they both have? So they both can't share 45 because 18 isn't that big. So, okay, go down to the next biggest number. All right, for my friends at home, we hope you are well. We hope to see you soon. Have a wonderful day.